Hello everyone, welcome to Ferdinand Tutorials. I hope you're doing well. Today again, we want to continue from where we stopped in our last video. So, in our last class, we were talking about food constituents, where we talked about the different food constituents and why they are necessary, in the body. So last class, we talked about carbohydrates, I mentioned proteins, I mentioned lipids. So today, continuing with minerals and vitamins. Minerals and what? Vitamins. Now, when you hear about minerals are essential nutrients, they're essential food materials that are needed in the body. Now, we have what we call the macro minerals, and then we have the micro minerals. When we are talking about macro minerals are actually the minerals required by the body in large quantity, more than 100 mg per day. That is the quantity of the macro minerals, or the quantity of those minerals we call macro, are required by the body, in large quantity, and is estimated as 100 mg every day. So the body needs more than 100 mg of macro minerals every day. So when you hear about minerals that are needed by the body in large quantity, and then we're estimating the quantity to be more than 100 mg each day, we call those minerals macro minerals. Example, we're looking at potassium, we're looking at calcium, we're looking at phosphorus. Are we together now? Now we have the other types of minerals called the micro minerals. Now these minerals are required by the body in small quantity, in a quantity estimated to be less than 100 mg every day. Now we're looking at minerals like we have the manganese, we're looking at minerals like the iron, we have cobalt, we have copper. Are we together now? These are the micro minerals. So they are essential for the body's metabolism. That is that for minerals. Now we also have the next food constituent, which is vitamins. Vitamins. Now vitamins are essential for the body metabolism. That's why we have the water soluble vitamins, and then we have the fat soluble vitamins. Water soluble vitamins don't stay long in the body. You understand? There are vitamins that don't stay long in the body. So when they come, the body moves them out. As opposed to fat soluble vitamins, which stays longer in the body and then also risk toxicity. Do you understand? So when the mineral stays longer in the body, it risks being toxic to the body system. Now we have some fat soluble vitamins, which is what we call the ADEC. Are we together now? Which is what we call the ADEC. These are fat soluble vitamins. We have vitamin A, vitamin D, vitamin E, and vitamin K. Are we together now? Those are fat soluble vitamins. Now we have water soluble vitamins. In water soluble vitamins, we have the ascorbic acid, which is the vitamin C. Are we together now? We have vitamin B1. Are we together now? Which is the thiamine. We have vitamin B2. Are we together now? Which is riboflavin. We have vitamin B3. Are we together now? We have vitamin B5, which is pantothenic acid. We have vitamin B6. We have vitamin B7, which is biotin. Are we together now? We have vitamin B9, which is folic acid. We have vitamin B12, cobalamin. Those are water soluble vitamins. They are water soluble vitamins. So that is that about vitamins. Now there are different functions of each of these vitamins. So I would like you to know each of them. There are functions. You understand? So in case they come out in exams, remember, so that you know it, and then you don't say, okay, Sir Ferdinand didn't talk about it. So I just want you to maybe, in your spare time, look at some of the functions, of these fat soluble and then water soluble vitamins. Are we together now? Good. So now let's talk about enzymes. And that's it. Remember, this is the book we'll be using, this is the book you're using, and this is the book I'm using to teach you. So another thing we want to discuss here is what we call the enzymes. We call it enzymes. Enzymes. When you hear about enzymes, what comes to your mind? When you hear about enzymes, what comes to your mind? Now, before I explain enzyme, that is what we call catalyst. Now, and then catalyst is grouped into enzymes and then inhibitors. Now, when we're talking about catalyst, we say that catalysts, are organic substance that alters. Mark the word, alters. That alters the rate of chemical reaction. Those are catalysts. Now under this catalyst we have enzymes, and then we have inhibitor. So when we say alters, that means it either increases it or it either stops it. So enzyme on its own are biological catalysts that speed up. That means it increases the rate of chemical reaction. Now when we're talking about inhibitor on its own are also biological catalysts that slows down, that stops chemical reaction. So we want to look at this one that speeds up what chemical reaction, which we call what the enzymes. Are we together now? So we have some enzymes in our body that help to speed up chemical reaction. And then have you wondered why you eat carbohydrate and then it will not stay long, your food will digest? You eat proteinous food, it will not stay long, your food will digest. Now, apart from this enzyme which speeds up chemical reaction, you begin to see that our food will take even up to 24 hours to digest. Are we together now? So we have, enzymes that are responsible for carbohydrates, which we call the amylases. Amylases, Amylases. Amylases. They are enzymes that digest what? Carbohydrates. We have proteases. They are enzymes that digest what? Proteins. We have lipases. They are enzymes that digest what? Lipids. Are we together now? So enzyme is necessary, you understand, for the digestion, for the metabolism that happens inside of our body. Are we together now? So we have 6 classes of enzymes that you should know. We have 6 classes of enzymes that you should know. Now we term them OTHLIL. I taught this in the tutorials, OTHLIL. I will just give you the meaning of the acronym and then explain some of the few things you need to know about them, and then we'll continue running. Now we have OTHLIL. These are the 6 classes of enzymes. We have O, oxidoreductases. We have T, transferases. Before I continue, I always love my students to don't just watch this video. Please make sure you have your notes, your jotter, anything that you used to take these notes down. Because if at the end of the day what you do is you watch this video and you don't actually write something down, there is high probability that after watching it and then you love it, you love this video, you shared it, and then you subscribe. If you're a new subscriber, you forget everything at the long run. So I'd prefer you to get a note so that you write some of these things down. It's very, very important. Are we together now? So now OTHLIL, back to what I was saying. I said that O is oxidoreductases, T is transferases, H is hydrolysis, L is ligases, I is isomerases, another L is lyases. Lyases, Lyases. Are we together now? Good. So let's explain oxidoreductases. Now these are enzymes. When we're talking about oxidoreductases, they are enzymes that catalyze what? Oxidation reduction what? Reaction. In your chemistry, you've heard of oxidation and then what? Reduction. So they are what? Enzymes that catalyze oxidation reduction what? Reaction. We have the oxidases. We have the reductases. Those are the what? The enzymes. Transferases, they catalyze what? Group transfer what? Reaction. Now when we're talking about hydrolysis, now hydrolysis, they catalyze hydrolysis what? Reaction. You know what is hydrolysis? The splitting of what? Of water. Are we together now? So they catalyze what? Hydrolysis was reaction. When we're talking about lyases, Lyases, they catalyze addition of groups to double bonds. They catalyze what? Addition of groups to what? To double bonds. And then isomerases, they catalyze transfer of groups within a what? A molecule. And then ligases, Ligases, they catalyze what? Bond formation. Now when we're talking about bond formation, let me explain that one in particular. Bond formation, we're looking at something like C, they catalyze this. We have CN. Are we together now? We have SN. So they catalyze the what? The formation of what? Of this bond. These are why we call them what? The ligases. So that is that. Another thing we'll be looking at is some of the properties of enzymes. Remember that first of all, enzymes are proteinous in nature. They are what? They are made up of proteins. Are we together now? Now we also say that enzymes are they help to speed up the rate of what? Chemical reactions. Are we together now? So another property is that they are soluble biomolecules. Now there are many biomolecules in the body of a living organism. We have protein. Protein is a biomolecule. Carbohydrate is a biomolecule. Nucleic acids are biomolecule. Lipids are biomolecule. So enzyme is one of the soluble biomolecules because enzyme is what? Protein. Meanwhile, protein is what? A complex molecule, a biomolecule. So enzyme is under it. Are we together now? So that's why we say that enzymes is a what? Soluble biomolecule. Enzymes are organic catalysts. I've said that also. They are specific in their action, that is, they catalyze only one reaction. Look at what this simply means. If we say that enzymes are specific in their reaction, simply means that when we talk about amylases as enzymes, that catalyze digestion of carbohydrates, that is to say that these amylases cannot act as proteases. Proteases cannot act as lipases. Lipases cannot act as amylases. So these particular enzymes are specific in the what? In the reaction they catalyze. Are we together now? So another properties here is that they are best at a particular pH ranges. Some enzyme act best under acidic pH, while others act best under what? Alkaline pH. So also it is important to know that there is no enzymatic activity that takes place in the stomach. There is no digestive activity that takes place in the stomach. Why? Because of the hydrochloric acid content of the stomach. So what happens in the stomach is what we call churning. Only what? Churning. There is no digestive process that happens in the stomach. So I want you to know that when there is no digestive process, that simply means there is no enzyme that is found in the stomach. So I hope you got something from this video. If you have any question of any particular sort, ranging from minerals, ranging from vitamin, or ranging from the constituent of food materials that we discussed earlier, talking about carbohydrates, proteins, and lipid, or even some of the properties of these enzymes and meaning, do well to ask your question in the comment box. I will do well to answer. And meanwhile, I'll be attaching a video I made about fat and water soluble vitamins, so that you also watch and learn more about them. It will also be in the description below. So I want you to share this video, please. I want you to share this video as a year one student, as someone who loves undergrad. I want you to share this video to someone who you think that needs this video. Share it to them, tell them to watch, and also to like this video. And if you've not subscribed, you know how we do it. Please click on the subscribe button. See you again in my next video. Bye for now.